Okay, today grade 11s will be looking at nature of roots. So basically, in nature of roots, the thing that you have to know is what do they mean by nature? Then what do they mean by root? If you need this document is there. Academic level up. This thing is there. So recently session throughout the week. We're gonna continue like this and have 3 sessions per week: Friday, Saturday, and Sunday. If something happens, maybe because of load shedding or whatever, the sessions still gonna continue. I will upload the videos of everything. Today we are finalizing everything relating to algebra. We will do simultaneous equation, we'll do the nature of roots, which is the one that we're starting with, we'll do K-substitution, we'll do inequalities. These are all the things that I haven't explained yet in terms of algebra. Then after that, we're going to trigonometry, nice part of math. So basically now, let's take a look at the nature of roots. Nature of root. Sorry. So let's let my PC to comprehend. It's a little bit doing something. It's okay. Nature of roots. This is the nature, right? What is the nature? We know that the nature of something is the way in which something it was since from creation. Let me not go far, because if in creation, I can get into life science, geography, whatever. So let me now explain mathematical terms. Okay, if here you can see, they said nature, this is nature, refers to the type of number that the roots are. The type of numbers that the roots are. Remember, we got a lot of numbers. We got real numbers. We got non-real numbers. We got rational numbers. We got integers and fractions. We got whole numbers. We got natural numbers. There is a lot of numbers that you can deal with. You can just go and look at this document and check the kind of numbers that we have. But I explained in one of my videos that what kind of numbers do we have, right? So here, as I said, we'll be looking at the nature of roots. We'll be looking at the type of numbers the roots are. And again, we'll be looking at roots. Every time when we talk about roots, we're talking about X values. Don't be fooled. I don't care who that professor might be, but every time when we talk about numbers, values, we're talking about when we're talking about roots, we're talking about X values. Basically, we're talking about X intercept solutions, zeros of quadratic equation. Remember, quadratic equation is always in terms of X or Y. So basically, let me not limit you in terms of saying X intercepts. Let me say any kind. Can be K intercepts. But let me not K intercepts. Can be Y intercepts. These things you're gonna learn them more at university. Can be also here it is Z intercept instead of K, can be X intercept, because a Cartesian plane does not end in 2D where we're talking about X and Y. It doesn't end in 2D, it ends in one, in 3D space. 3D space. But you at high school, you're more focused in 2D. That is what we're gonna be focusing on. So basically remember, when I'm talking about roots, we're talking about X intercepts, solutions to quadratic equations, and we're also talking about zeros. So basically when you solve a quadratic equation, you get a solution. That solution, we call them roots. So basically that's why I say when you're talking about roots, we're talking about X values. Immediately you see X values, those are roots. This is how we comprehend this thing. Let me erase this thing and get into details. So I want to show you the derivation of everything. We got quadratic formula. Let me decrease this. It gives me some more bold weights and whatever. So I want to decrease this. Make this one. Okay. Immediately we're talking, we have a quadratic formula. Quadratic formula is given by this, which is x, which is equal to negative b plus or minus to the root of b squared minus 4ac divided by 2a. This is the quadratic formula that we know how to apply this quadratic formula, because a, they're saying a is the coefficient of x squared, b is the coefficient of x, c is the constant term. Whether it's positive or negative, you substitute it the way it is in the quadratic formula. You substitute it the way it is. So basically, we can conclude that this thing is from a quadratic equation, which is x squared plus bx plus c, which can be equals to 0 or something, depending. Then our a is the coefficient of x squared. Our b is the coefficient of x. Then our c is just a constant there. There's a constant term. That is how this thing it is. Then let's go further. The way we apply it, here we got an example. Let me try to zoom in, but it's fine. Let's leave it like that. It's fine. So we got 3x squared plus 2x minus 4, which is equal to 0. When we have 3x squared, let me write it down here, squared plus 2x minus 4 is equal to 0. We know that a is the coefficient of x squared, that means it's 3. Our b is the coefficient of x, that means it's 2. Our c is the constant term, and the constant term here is negative. Remember, the original formula that the original equation that I gave you, it was plus c, meaning our c is going to be -4. Remember, always like that. If it confuses you, it just says here from the original formula, our c is positive, right? This thing is going to be equal to -4, like this. This is the way in which it is, because here is always positive, meaning when you write it here, you have to put negative. Remember, I'm saying every time when you substitute the value of a and b and c, write the number the way it is. If it is negative, a is equal to negative that number. If it is positive, a is equal to positive that number. Same applies to b and c, like that. Don't confuse yourself. Then you just plug in this equation. Then after plugging in this equation, in determining the answer, add more plus or minus. Now, one more plus or minus is either going to use positive for the first solution, then you're going to use negative for the second solution. Positive for the first solution, negative for the second solution. Always like that. Remember, positive first solution, negative second solution. Always, doesn't change. Always like that. So let's go into details. Then from the quadratic equation, that is where we find something called the discriminant. The discriminant is going to help us to determine the nature of roots, to be able to know whether the roots are either real or non-real. That is what we call the discriminant. Okay, so the discriminant, as you can see here, is b squared minus 4ac. This thing is indicated by something that we call it delta. This is delta. It's represented by delta. Delta is the discriminant and even shows the nature of roots. So basically, when we're talking about nature of roots, we say determine delta. Determine delta. Okay, going into details now. So here we got delta is equals to b squared minus 4ac. So let me go into details somehow on how to apply the delta. If you are able to determine x values or solution or x-intercepts of a quadratic equation using quadratic formula, you can be able to determine the discriminant or the nature of the roots. When this is discriminant, determine delta, and we know that our delta is equal to b squared minus 4ac. Why does this b squared minus 4ac come from? From the quadratic formula. I'm going to go into details. Don't worry, this thing is very, very much simple. So here we have 3x squared plus what? 2x minus 4 is equal to 0. Determine the nature of the roots or determine the discriminant. When they say determine the nature of roots, I'm going to explain more. For you to determine the discriminant of the nature of roots is that delta is equal to b squared minus 4ac. This is the formula that we know about determining the nature of the roots. But remember, each and every time when your equation has no unknown and it says the nature of roots, you have to determine it like this. When there is what? No unknowns. And remember, don't be fixed-minded. Always read the question properly. When they say determine the nature of the roots, you have to determine delta. So for delta, and on top of that, you have to tell us whether the roots are real or non-real. But I'm going to explain this more. So delta is equals to b is what? Is 2. Remember, b is the coefficient of x. 2. What? Squared. Minus 4. Our a is the coefficient of x squared. That is 3. Our c is what is the constant. This part we substitute as a negative 4. Then from here we're going to have 4 minus 12 times negative 4. Let me perform calculations. Okay, we've got 4 minus 12 times negative 4, which is 52. As you can see, our delta is positive. That means the nature of the roots of x3x squared plus 2x minus 4 is real. That means here we're talking about real roots. The real roots. The roots are what? Are real. Simple as that, right? I'm going to explain why I'm saying when it is positive, the roots are real. When it is negative, the roots are something else. I'm going to explain more. Don't worry. Let's go into details now. Okay. Remember, always when they're talking about determining the nature of the roots, we're looking at what? A parabola. Remember, algebra is linked to everything with regard to math. So, a lot of things that we deal with, we're looking at a parabola, right? A parabola. So let me erase some things here to indicate things properly. If we're talking about two real roots, you see, two real roots in our parabola, it will be the intercept. We said is the x-intercept or the solution of a quadratic equation. You see, it's those points or this point when our a is negative. Remember, here our a is positive, here our a is negative. That's why the parabola is concave downwards. Then one real root, it means it has one solution. One real root, one solution. Two real roots, two solutions. Remember, the real root is there, but we'll be dealing with cubic functions. Those things you're going to learn them more when you go to grade 12. So here, one solution is, that solution is here, is only the x-intercept that we have. Remember, we said roots is the x-intercepts, or solutions, or zeros of a quadratic equation. Quadratic equation, parabola, right? So here, also, negative, is one solution. Here, there is no solution. No, zero solution, right? Sorry about that. There is solution. It is zero solution. Zero solution because it is where our parabola touches here and x is equals to 0 at this point. Then we say 0 real roots, right? Even here, the same thing applies, 0 real roots because x is equal to 0 at that point. You see, that is how we determine the nature of the roots. And remember, the reason why we say x-intercept is because your quadratic equation will always be given being equal to 0. Then from there, because it's equals to 0, that is why we'll be saying what? X-intercept, right? There is a situation whereby your quadratic formula can have no solution, right? Then from there, we cannot determine the nature of the roots. It's not applicable. Why? The nature of the roots are not possible to be calculated at that particular point. Right. Right. Okay. Right. So, determining the nature of the roots. Nature of the root does not end where you are able to calculate delta. Your delta, b squared minus 4ac. No. They end where you tell us what is the nature of this root. What type of number is this root? Is it a real number? Is it a non-real number? Or what is happening? But I'm going to explain everything in details. So, the discriminant is used to determine the nature of the roots. What is our discriminant? Our discriminant is delta. I'm going into details. Don't worry. Delta. So, what is happening here is delta can be negative. When it is negative, the nature of the root is no real root. Basically here, non-real roots continue to be non-real, right? Non-real, if you don't want to say no real roots, you can say non-real because the opposite of real is non-real. But I scientifically and mathematically advise you to use non-real. I'm not saying no real is wrong. It's still correct, but I'm advising you to use non-real. But any is correct. Right. Wait, let me fix this pen. I want to use this red. I want to change colors. Get color blocking on. So here, if your delta is greater than or equal to 0. Remember, greater than or equals to, as inequalities is positive. I'm going to explain this inequalities again, but we're going to be fast because I explained in one of my previous videos. Then here we have delta less than 0, which is negative. You see, this one is negative because it's less than 0. This one is positive because it's greater than or equal to, even if it's greater than it's positive. Even if it's less than or equal to, it's negative, right? Less than, equal to, negative, right? The roots are what? Are real, right? If delta is equal to 0, we're talking about 2 equal roots. Basically, I just like to say the roots are equal. That is according to my perspective. Equal, right? Then we've got 2 real roots. The roots are real and they're equal, right? When delta is greater than 0, 2 unequal roots. 2 unequal. When we're talking about this, talking about 2 unequal roots, because the roots are what? Are different. That's why it's greater than only. 2 unequal roots. If it is greater than or, if it delta is equals to, we're talking about 2 equal roots. Greater than and less than unequal. Because greater than means the other one may be greater than the other one. Or the other one, less than means the other one might be less than the other one. So here, we're talking about unequal roots. Even here, more, we cannot talk about unequal roots because this thing is non-real. If it is non-real, it doesn't exist, basically. Right. I'm going to explain things more pertaining this. Basically, I'm going to explain things more. Okay. If delta is equal to a perfect square rational root, you conclude or the roots are rational. If it is equal to what? A perfect square. A perfect square. Okay, a question. What is a perfect square? What is a perfect square? What is a perfect square? Because a lot of people, they experience problems in maths, not because they are unable to solve, but because they are unable to determine, to know certain ways. Remember, here I'm going to be old school, but I'm going to recite, going to internet, which is not an old school thing, right? Go to internet every time you see, or now they're talking about a word that I don't know, and search perfect square meaning. As I searched here, I searched it because I want to lead by example and explain it from Google. It says, in mathematics, wait, what is a perfect square? When 2 identical integers are multiplied together to form a number. When 2 identical integers are multiplied together to form a number, that is a perfect square. When 2 unequal, 2 identical integers are multiplied together to form a square. This is according to Google. More, now according to my observation is that a perfect square is any number that you can write it in terms of squared. That's a perfect square. Immediately that number, for example, if you got a 16, right? 16 in the calculator equals to 16 equals to, then you go again and say shift fact, right? Shift fact on the calculator. Let me calculate it. Shift fact is 2 to the exponent 4, right? And we know that 16, for us to have it, it has to be 4 times 4. You see, 4 times 4. Why? This thing is 4 squared. Even any number that can be written in form of squared, that thing we call it a perfect square. You see, perfect square. Perfect square, right? Because according to the definition, it says when 2 identical integers are multiplied together to form a number, meaning that number, number one, so form again the 2 identical integers. That's one. The integer can a negative number or a positive number. Okay, fine. We go on. We'll be fine. So basically, if you have a question based on this, come to my WhatsApp tell me, Benny, I have a problem with this. Then from there, we're gonna explain more in terms of this. Then here, if your delta is not equal to a perfect square, meaning it's not equal to a number that can be squared to find that particular number. For example, 4 is a perfect square. Why? Because two integers can be multiplied to give you this. It's 2 times 2, and from that instance, it's 2 squared. Remember, squared. Every time when a number has a squared on the top, you can say what is a perfect square. So basically here, it's not a perfect, like, it's not equal to, like, delta is equal to a number that is not a perfect square. That's why they say delta is not equal to perfect square. So here is equal to a number that is not a perfect square. If it is equal to a number that is not a perfect square, we conclude that it is irrational. Right? Is an irrational? Because the roots are real, but irrational. I don't know what I'm doing here, but something just changed. Okay. There. Irrational. Right. So it is irrational. If that is equal to a perfect square, you can tell me that the roots are rational. Okay. The roots are real and rational. Real and rational. Okay. As I'm inside the roots, I want to explain something quick about, because I explained about non-real and stuff. So I want to tell you something that a lot of people, they don't know. If you have fraction, right? Fraction. We don't go outside this group, but I just want to explain this. Fraction, right? We've got x minus 2 and x plus 4, right? Maybe we got this. Or maybe they give you a root, right? The values of this equation in which I mean the values of x in which the equation is undefined. Let me not say the equation. Let me say the expression is undefined. Undefined is different from non-real. Undefined is when the denominator is equal to 0. If 4 is equal to 0, undefined. X squared equal to 0, undefined. Right. This is what we're talking about, undefined. Undefined, right. I just want to explain this important concept. Then if they say determine the value of x in which this equation is undefined, meaning the denominator has to be equal to 0, then it says x plus 4 is equal to 0, right? X is equal to -4. At this point, if x here is -4, that means we have 0. This expression is undefined. Non-real occurs when a number inside a root is negative. That is where we're talking about this non-real here, negative. So basically, for you to find non-real in discrimination, you don't have to perform calculation. You just perform calculation, but immediately you get a negative number. It's non-real. Why is it non-real? Because in terms of quadratic formula, we know what here is our delta. Here is our delta. So where our delta is, because here is equal to b squared minus 4ac, right? Divided by 2a. If this part is negative, is inside what? A root. This is a root, as you can see, it's a root. If it's equal, is this part is negative and is inside the root, that means it's what? Non-real. That's why this gives you a non-real number, or no real roots. You see, that is the ambiguity that I needed to remove. Okay. Let's go further. In maths, they can try to confuse you, whatever they can try to do, but I'm guaranteeing you, you will never be confused. As long as you can listen to what I'm saying. Don't be ignorant in life. Listen when we are teaching you guys. But besides that, if they're teaching you things that correspond to what you read within the book, from there, everything will be fine. Okay, so here I'm going to explain the nature of roots again. Today we're finishing about algebra. I'm going into details now. There's no time. Going into details, then you do your self-study. I'll give you assignments to write. Then from there, you'll come and we'll see basically from your assignments, or are you coping with this now? If not, I'll keep on giving you assignments and explaining, doing corrections from previous question papers. Then from there, for sure, you'll get what is happening from algebra, because these things are simple, right? Simple. Okay. Remember, if it's not a perfect square, it's irrational. If it's a perfect square, it's a rational, the number, right? So here we got an expression, right? We determine the discriminant. Let me just say the nature of the roots, right? The nature of roots basically is the expression of what the root is. Number of real roots, right? Here they're just giving me the number of real roots. Here is b squared. Remember, our a here determines the shape of our parabola. Remember, I said always in algebraic expression we deal with a parabola in a lot of situations. Parabola. Even in function, taking consideration the information parabola you will in function issue or algebra. There's no way they can fool you as long as you know the principle of mathematics. Okay, here we got x squared plus here we got x squared plus x plus 1. Remember, the most superior to another a, b, c, k. Read the a is the number in front of 1. B is the number in front of x. I mean, a is the number in front of x squared. B is the number that is in front of x, the coefficient, right? Plus 1 is the constant, right? Then here we make a direct substitution. You can see your 1 is there, your other ones are there. Then from there you get a negative number. When we get a negative number, because delta is less than 0, we have what? What is the nature of the roots? Non-real. Non-real, just like that, non-real. More a number of real roots. Basically what we need for you to write the question, just to know this. But I'm going to make a further explanation to make you understand more in terms of what I'm saying, right? And then the number of real roots, 0, right? Then here, if our a is positive, meaning this is our equation. This is our equation. Because it's non-real, we don't have x-intercept, basically. Let me explain it better. The graph is going to be like this. The number of real roots, there is no real roots, bro. Meaning this equation does not intercept the x-intercept. Remember, repeat again, nature of roots, roots represent the x-intercept. It does not intercept. You see, that is from that instance, when it does not intercept the x-axis, we will say no real roots. That's why we call it non-real, right? So here, we got this equation. When we substitute it into this equation, we got delta which is equals to 0, right? Substitution, you know, I explained from the first one, do the second one. The second one, do the same thing. Rho, we got 0, and 0 is a perfect square because 0 squared is 0. Am I wrong? No, it's a perfect square. Then real roots is a real root, is equal. When it is equal to 0, is a real number because 0 is always positive. There's no negative 0. Even if even a calculator if got negative 0, it will tell you even the way it's programmed, right? Tell you 0, positive, right? Then it's a rational number because it's a perfect square. Why? 0 squared is 0 and is equal. The roots are real, equal, and rational, right? Number of real roots, we got 1. 1, because it touches at 1 point. One real root. You see, at that point, touches at 1 point. When it doesn't touch at the x-axis, meaning non-real, when it touches, there is 1 real root. Sometimes they can say determine 1 real root or 2 unequal. If this unequal is greater than there is not equal to, right? So again, here we have this one. It's a lot. Okay, we have this one. We've got a positive number. A positive number means the roots are real. And you check 49 or is it a perfect square? It's a perfect square. It's a real perfect square and unequal. It means it has 2 real roots. Why? Because basically what we're going to get 2 real roots. Look at this parabola, right? If it's a real, right? Real, and real, it can be real but have 1 root, but here has 2 roots. For you to know is to draw a parabola or how many real roots are there. So you can see this parabola, it will intersect at this part and that part. Then we say there is 2 real roots. That is how you have to determine this. Also here, it touches this point and that point, 2 real roots. Then here we've got a positive number but it's irrational because this is not a perfect square. As you can see, I said perfect square is the number that you can multiply it with another integer and give you a square. The same one, the same number. Like I said, is any number that it can be squared. Right. So if you don't get the definition again, go to Google it. No. Best thing is to know right now than to know later. Let's look at a few questions. I didn't write the questions here, so I'm gonna just shift a little bit downwards and take a very difficult question from your apps. Okay, I need something strict of the nature of the roots. Okay, we've got a question here. They says, wait. Look at here. They told you already the nature. They says, calculate. Oh, sorry about that. Okay, let's go into details. They said calculate. This is calculate the value. I just want to write it down so that we can see of D for which, right, which 5x squared plus 6x minus D is equals to 0 has equal root. Remember, they already told you that this equation has equal roots. And we know that equal roots is where delta is. Let me show you. Because sometimes you tell people, they think, oh, this guy. Let me show you where this thing comes from. Let me show you. It comes from here. Here, as you can see here, let me try to erase to facilitate everything to make it simple. You see, it comes from here. If you can see here, the nature of the root they said they are what equal. This is this. This is what we are talking about. This is what they are equal, right? Two equal real roots, right? So here we're gonna say delta. We know. Remember, we already know is equals to 0. Why? Equal roots. We need D. D is what? Our constant value, right? Remember, the roots are what? Equal. Then we just use delta. Then here is b squared minus 4ac. Oh, yeah. Then ac is equals to 0. Then our b is the coefficient of x, which is 6. 6 squared minus 4. Our a is 5. Then multiplied by c is equal to 0. I mean c, which is negative d here. Sorry about that. Let me erase, write everything properly. As this is going to be 5. Negative d equals to 0. Okay, there we go. So 6 squared, how much is 6 squared? 36 minus 12. It will be positive 12 because here is negative and here is negative. Negative multiplied by negative is positive, equal to 0. 12d is equals to negative 36. Then your d is equals to negative 36 divided by 12. Then you get negative 30, negative 30. Then this is the value of your d. Calculate the value of d for which this has equal roots. Equal roots means that the roots are equal to 0. That is what we're talking about here. Right. Something like that. Don't be confused. Always like that. Don't ever try to be confused. Remember, if they told you what is the kind of the roots, then from there you just have to use the nature of the roots. If they say the roots are greater than, so if you say this thing, or delta greater than 0, right? If the roots are real, if the roots are non-real, use this and determine the value of k for which the roots are non-real, right? Then if the roots are equal, use this one. If the roots are real, use this one. If the roots are non-real, use this one. That is one of our examples. And I give you more problems based on this to practice. Okay, let's take a look at the other things that I want to look at. Let me look at inequalities first before we go to K-substitution. So inequalities, we have signs of inequality signs. So we have greater than or equal to, right? These things, they mean positive. We've got less than or this is or less than or equals to, which means negative, right? Then again, from here, just have to know, in inequalities, we deal with a what? Parabola. Parabola. Our parabola is a function of f of x, which is equals to ax squared plus bx plus c, right? This is what we call parabola. Then from here, our parabola is positive, is happy, is like this in shape, if our a is positive, and our parabola is concave downward if our a here is negative. If our a is negative, concave downward. If our a is positive, concave upward. Happy. Here is happy. Here is sad. See, conditions of the parabola. Simple as that. If you know this, you're done. If you see these signs, they mean look at our graph where our graph is positive. If it's like this, look at our graphical representation and check where our graph is negative, right? So I want to show you something. The graph that we're gonna draw, graph. Now I use a very simple method, but there is another approach that you're gonna use, but I'm not gonna explain it. But if you need me to explain it, come to my inbox, tell me, Benny, explain 1, 2, 3. I'm gonna explain it surely, right? So look at this. Our graph. Let me not say graph. Let me just say our sketch. Sketch say or solution. Solution. The sketch is gonna be straight line. Let me go crazy. Okay, it's gonna be a horizontal line like this. This horizontal line is our x-axis of the Cartesian plane. Right, is our x-axis of the Cartesian plane. We know Cartesian plane is like this, right? We know why is here they are positive, here they are negative, right? So we're not gonna draw this line. We're gonna eliminate it. This is our Cartesian plane, but we're gonna eliminate it. What we're gonna do in a test is that, let me erase this part because we don't need it. This one. What we're gonna do in test, just draw your x-axis. So this one, my x-axis are positive, like a Cartesian plane. Kafas go negative. Then here you're gonna find critical values. Critical values. Basically, your critical values are the x-intercept of the parabola. Then, if in front of a of your parabola, if your a is positive, remember your a is the coefficient of x squared, is the number in front of x squared. If the number in front of x squared is positive, that means your graph is what? Is happy. Then what we're gonna do here, we're gonna draw a happy everlasting graph in a relationship. I don't know, but I'm just saying it's happy. This intercept is your x-intercept of the parabola, right? So if they says where your graph is happy, whatever equation greater than or equals to 0 or greater than. Remember, greater than or equal to and greater than. We test the parabola using the same thing. Then here they say is where is our graph because of this sign? Where is our graph what? Positive, right? Our graph is positive above the x-axis, which means it's positive from this x-intercept going that side, and from this x-intercept going that side, right? Then our solution is going to be x less than or equal to, because more is greater than or equal to, you're going to use less than or equal to here. And I'm going to explain why. Critical value. Your critical value is that value. And this value has to be smaller. Has to be smaller than this value. This one has to be bigger. You see, has to be bigger. This one has to be smaller. I think this is the best explanation. Listen. So again, x less than, because we need all the values that are less than our critical values. Less than all the values that are less than. Greater than all the values that are greater than our x value. Why? Greater than. Everything that is big dot. If we have a Cartesian plane like this, we know it's always 0 here. These numbers from this side, 1 here, 2, whatever. The numbers from this side going that side, they are bigger. They get bigger and bigger and bigger. To infinity, right? Bigger and bigger. Then from that instance, from this point, from a point to the right, greater than. From this point to the right, here, remember the right, greater than. Greater than. Remember, it can be greater than or equal to. That equal to, and greater than or equal. That equal to, we mean this critical value is equals to this function at this point. Equal to, they intersect. Greater than, so greater than is to the right, always. Only what do you like at this? This inequality. Right, to the right, relativity greater than or equal to, right? Right. The sign it. We want to greater than or equal to. We want to greater than fair. Then more, left. Utoma koduma Cartesian plane to the left. More graph ya wa wana graph aga igam. It is part. Ridobalaga less than. And less than yao. It over less than what your critical value, or less than or equal to. Always, if it's to the right. To the right, I mean, if it's to the left, less than or equal to less than. To the right, greater than or equal to greater than. Right. That is the principle. Then remember, the reason why I'm saying my solution is x less than critical value, this critical value, is because, look, from this point, from this critical value, going this side, graph this line here, x-axis. Because this line x-axis, we're going to conclude our graph is positive, because x-axis is positive, graph gain negative, always like that. This thing doesn't change. Don't be confused. Then here, we're going to say or. Remember, this is our solution. Or what? X is greater than or equal to CV. Why greater than or equal to? Greater than or equal to because moki greater than or equal to. And the reason why I get the equal or greater than is because more equal or greater than. Then why I get the greater than or equal to? Because from this point going to the right, that is where, from this point going to the right, that is where graph is at the positive side of the x-axis. Then from that point, we're going to conclude that because I said to the right is greater than, madala, greater than, always like that. Don't be confused. Nothing confusing here. Explaining more. Remember, they can give you an x squared. X squared. This thing is getting somewhere. Okay. We have an x squared, right? X squared. In front of this x squared, maybe we have a negative number. It's negative. We don't know. It can be 1. It can be it can be -1, -2, -3, -4, whatever. Then we have an equation. They says Braga. Madam, whoa, reshumisha greater than, right? Greater than is 0. Remember this one. Kimolograph positive. Molograph positive. Then what we're gonna do is find critical values. I'm gonna show you a similar example, maybe 2 or 1, depending because of time. So what is gonna happen is, remember in front is negative. Can it be is negative number? Going to draw the x-axis. X-axis. What is happening to the x-axis? Here we write our critical values, which is the x-intercept of this parabola. Then remember in front of x squared is negative, that means our graph is sad. Sad. We didn't draw this, don't worry. Sad. So what guy, let me draw this thing properly. You know, what excuse what you don't understand. Okay. Let's go. We did simple, this straightforward. More. That is where our graph is what? Positive, because positive is above the x-axis. Come, above. Below. English, below. So come, be negative, graph negative, come positive. Because graph positive because of greater than. That means our answer is gonna be from here going to that point, because graph is positive, positive graph that the solution to be from this CV to that CV, right? Then answer another worry CV. Remember, this CVs, they're not equal. I just wrote CV because critical values greater than less than greater than less than x, greater than CV. CV which is greater than x. You're gonna write it like this. Even if there is equal to nyana more, you're gonna add that equal to here, like that. So basically, from this point to that point, from this point to that point, we write it like this, because this is no starting here and ending there. Always like that. Let's look at a smaller example showing you what this principles truly works. This principle works. Let me look at a question from here. Okay, they given me x squared. Remember, I solve for x. How to solve for x? 2x minus 8 less than 0. As I said, this is our parabola. When I'm talking parabola, I'm going to read x squared like that. Parabola is like that. This is our parabola. So what is happening? Firstly, determine our capital x squared, positive or negative now, positive. That means our a is what? Is positive. And now our a is positive. You can say it left before you write. Scribble. Because it's positive, then the shape of a graph becomes like that. Less than. Because less than imminent negative. Which means is where our graph is negative. Where our, this is our guys, graph is negative. Yeah, negative. Where our graph is negative, then the question is, how are we going to solve it? Firstly, find factors. Find factors. Factors gonna form part of your x-intercept of this graph, right? Get the x-intercept graph. So what is happening is, be smart. We're gonna find factors of 8. Factors of 8, which when you add them or when you subtract them, you find the middle number. The factors of 8 is 4 and 2. 4, if you add it, you get 6. That is not this number, right? These are wrong. But that doesn't mean all these things, they are wrong factors of 8. They are correct factors of 8. But if you can say it's negative 4 plus 2, you get negative 2. That is this number. That means we conclude that these factors, they are correct to use in our answer. So here we'll be having this bracket, x minus 4, x plus 2, sorry, less than 0. I'm writing fast, that's why that was this thing. Okay, what's happening here? Go on. Okay. Okay. What's happening here? We're gonna say critical values. Critical values, I said, is your x-intercept. So you're gonna set this to 0 and set this to 0. It can be x minus 4 equals to 0. X is equals to 4. Or x plus 2 is equals to 0. X is equals to negative 2. This is x. Don't be confused. Then graph like this. This is the x-axis. This graph is positive, below is negative. Negative. Then I said here, you put your smaller number. Here, you put your bigger number. Then your small number, it will be negative 2 to the left, positive 4 to the right. At the right side, positive number. At the left side, negative number. Okay. Remember, our graph is what? It's positive. Then you sketch it. Yeah, interceptor, negative 2. Yeah, so interceptor, 4. Going like that. Remember. Then after drawing, then this sign comes in for interpretation of where is your solution. Comes in. Because this sign we should where is the solution? Then here it says where our graph is negative because it's less than. Remember, less than where our graph is negative. Then our graph is negative where? At this point. And I said from this point to this point, we use this. And I said we add this smaller line when here is less than or equal to or greater than or equal to. Here is just less than, then our solution is going to be negative 2 x 4. Like that. Simple. And this is a solution. Or somebody can write it as negative 2 and 4. Don't forget, because it's x values, is x element. X element. You can write it like this, you'll get full marks. Write it like this, get full marks. That's all about inequalities. If you want to learn more about inequalities, text me. Say I need extra questions on inequalities. Then I'm going to give you questions to practice. Then after that, respond back. Tell me, Benny, 1, 2, 3 is giving me problem. Explain. Only like that. You see, that is how we're going to work this time. Okay, I'm done with inequalities. I explained this also in one of my previous videos, but now I want to explain one of the problems that one of my tutees came to me and said, Benny, I'm experiencing a problem with 1, 2, 3 K-substitution. She said something like, why do we apply K-substitution? That's why I said applying K-substitution. We use it when there is an ambiguous equation. Ambiguous equation one equation about that. More when solve the way no is gonna give you tough time. Here I'm switching. You see, then you will be needed to solve using K-substitution. K-substitution, we set the like terms to be equal. For example, let's start with number 1. Number one is this one. X squared minus 2x is equal to 18 minus 45 over x squared minus 2x. So here what I mean is, you can see this equation is complicated. And if you can check, like terms, x squared minus 2x and x squared minus 2x. This is what we call like terms. Giddy like terms are the things that they are alike. Giddy like terms. So how are we going to solve that? We're going to say let, remember always in math there is a language, let k to be equals to x squared minus 2x. This satisfies what I just said here. Applying this approach when having like terms in your equation, everywhere more than like terms in your equation, you can apply this equation. Even if you have maybe x squared minus 4 over x squared, which is equals to 7, you can apply this equation here because this is a like term with that. Then when you apply your k, you're gonna solve things easy. Remember, this equation is complex. If you try to multiply by x squared, it's going to give you x4 minus 4, which is equal to 7x squared, which is still correct, right? Which is still correct. Correct, madam. Correct. But the thing is, K-substitution is simplifies the situation. Listen, here we substituted here as K. Then our equation will turn to K, which represent this part, equals to 18 minus 45 over K. Then we're going to multiply by K everywhere. Then we're going to have K squared, which is equals to 18K minus 45. Why? 45 over K times K. That those K's, they'll divide each other, then we'll find 45. Then we're going to take this to the other side. We're going to have K squared negative 18K plus 45 equals to 0. Right. Then we need the factors. For this number, when we add them or subtract them, K here, K there equals to, then what 45 equals to shift fact. The factors is 9 and 5. Yeah, 9 and 5. And 5. These things, they're not correct, because when you add these factors, you get something like, when you add them, you get 14. When you subtract them, you get 4. You see? So these numbers are not the numbers that are here. Then wrong. Need another factors. 45 divided by. Let me try to find the factors real quick. Okay, the factors that I got is 15 and 3. When we add these factors, we get 18. So these are the real factors. Then here, remember here is positive. That means here is negative and negative. It's 15 and 3, which is equals to 0. Then you say K is negative 15 is equals to 0. K is equals to 15. Or K minus 3 is equals to 0. K is equals to 3. Remember, the question says solve for x. Then you're gonna equate this value and that value with what? With your x squared minus 2x. So it's gonna be, first let's say x squared minus 2x is equals to 15, right? X squared minus 2x minus 15 is equals to 0. Then the solution, here we know that the factors that makes this is 5 and 3. So obviously we're going to have x minus 5 because here is negative, x plus 3 because here is negative also equals to 0. Then your x is equals to 5 or x is equals to negative 3. Or x squared minus 2x is equals to 3. We're using this value for k. Then x squared minus 2x minus 3 is equals to 0. Then the factors that we have for this is x minus 3, x plus 1, which is equals to 0. Then here we'll be having, sorry about that, x is equals to, oh, what's happening? Is equals to 3, or x is equals to negative 1. As simple as that, then you got your answer. But always take in consideration, after finding the answers in algebra, put them in the original equation and see whether everything is correct. Prove whether your answers are correct. This thing is very, very much important. You know, go outside the exam knowing whether this thing is correct or not. Very much important. I'm not gonna do it here, but it's simple. Just take, if you take 5, substitute it at x there, substitute it here, and find the value, and see when we substitute the 5 here and here, you get the same value now. If you get the same value, is correct. If not correct, which means it's not equal to, right? I'm not gonna explain that again because I already explained it on my previous videos. Always prove. If you prove, everything will be fine. Then let's look at one of the problems. I don't know why people see simultaneous equation is hard. Okay, first we are going to explain what is the purpose of a simultaneous equation. The purpose of a simultaneous equation is for you to be able to find the values of x and y. Right? For you can find x, then you can find y. So what's happening here? We got our first question. We got this. Determine. This says determine the value of x and y simultaneously. Basically, everything you solve it at the same time. Then we're gonna let this equation be our equation 1. It's gonna be x minus 2y equals to -3 is our equation number 1. Then xy is equals to, is it 0 there or what's happening? Let me say is equals to 2, for instance, is our equation number 2, right? Then what's happening here, we say from 1. So the reason why I read from 1 is because we want to know, we want to make x or y the subject of the formula. But look at the one that is easy. Here, Moga, check out this one. X the subject of the formula easily. Here, it will turn into fraction. And a fraction is very, very much complicated to solve. But it's easy, but it's complicated. But it needs you to be good in math. So what's happening here, we're going to say x is equals to -3 plus 2y, right? Then this it will be our equation number 3. This is the equation that we're going to take it and put it here and try to solve our answers. Then we're going to say substitute 3 into equation number 2. Equation number 2 is this one. Then at x, we're going to substitute -3 plus 2y multiplied by y, which is equals to 2. Then multiplying, we're going to have 2y squared minus 3y. Then take this to the other side. We're going to have -2, which is equal to 0. Then here we're going to try to find factors. We're going to say 2y minus 1. I'm going to come back. Y minus 2. The question is, where are we going to have positive? It's here. Why? Because here is negative. Because if here is negative, the bigger number takes a negative sign. I can't explain grade 11 stuff. You're in grade 11. I mean, grade 10 stuff. You're in grade 11. But I can explain it. Come to my inbox and ask me, how is this thing? So here we have 2y is equals to -1. Then y is equals to -1/2. Or y is equals to 2. Just set these things to this to be equal to 0, this to be equal to 0, then solve for y. Then you're not done. You have to take these values and substitute them here, and take this one and substitute them here. Substitute them both. It's gonna be x is equals to -3 plus 2 -1/2, and we get our answer as -2. -4. If I'm not, because negative multiplied by negative minus -1 to be -4. Then x is equals to -3 plus 2 multiplied by 2. Then this thing gonna give us how much? 1. Then to prove, you have to take your 1, put it here. Put it here. Take your y, put it there. Put it at the y there. Then if it's equals to 2, it's correct. Then take again the same values. Your 1, put it there. Is it -1? No, it's +1, put it there. Take your -4, put it here. Let me see. No, take your, when you take your 1, you have to use even this y. This one with this one, with this number. Then here you take your 2, your 1, put it here. Your 2, put it here. You see, it's gonna be 1 minus 4, which is equals to -3. That means your simultaneous is correct. Correct. Then let's look at this one. This is our last question. Then we're done with everything pertaining algebraic experience. Just watch this video more and more to gain more understanding, or come to my inbox and ask. Then you're gonna set this one as equation 1, this one is equation 2. What's gonna happen is x minus 4y is equals to 5, right? Equation number 1. X squared minus 2xy minus 3y squared is equal to 0. Equation number 2. Remember, it's like that. Then we're gonna check an equation that is very, very much simple to make x or y the subscript of the formula, which is 1. Then we're gonna be like, from equation 1, we're gonna let x to be equals to 5 plus 4y. Basically, we just took this one to the other side. The same thing that we did previously. This is equation number 3. Right. Then here again, we're gonna take equation number 3 and substitute in equation number 2 into 2. Then we're gonna substitute this value where there's x. Then we first do have 5 plus 4y squared minus 2x. I mean, where is x? It is 5 plus 4y again, multiplied by y minus 3y squared equals to 0. Then this 5 multiplied by 5 is 25, right? Plus 40y, because 5 multiplied by 4 is 40, I mean it's 20. Then plus, obviously, plus 16y squared minus 10 minus 8y. Here's gonna be y again because we have to multiply these 2 and this y inside here in the same time. Squared minus 3y squared equal to 0. Then from here you look at like terms. If you can check, the like terms is 16 squared, 16y squared and minus 8 y squared. Then you're gonna minus them. 16 minus 8 minus 3. Basically, you try to add them because 16 is positive. It will be minus 2 by negative plus 2 by negative 8y squared plus by negative 3y squared. Then you're gonna get 5. Then we're gonna have 5y squared. Then the other like terms, it will be your 40y and negative 10. That is going to be 40 minus 10, which is equals to plus 30. Sorry about this. Let me try to 30y. Then again plus 25, which is this. It doesn't have 1 now. I need to lose channel now. Then divide by 5 here, divide by 5 to simplify the equation. Then we get y squared plus how much? 6y plus 5. I think this 25 divided by 5 is 5, yeah, equals to 0. Then here your y plus 5, your y plus 1. When everything is added, like here and here, you add everything inside the brackets. Then your y is equals to negative 5, or your y is equals to negative 1. Then you take this, substitute it into equation number 3, then we'll be having x, which is equals to 5 plus 4 multiplied by negative 5. Then you punch the whole thing inside your calculator and get negative 15 if I'm not wrong. Yeah. Negative 15. Then you go again, substitute it again. It's gonna be x is equal to 5 plus 4 negative 1, which is equals to 1. And this is your values. Then you prove it the same way that I did it last time. We came to the end of our session. In our next session, we'll be doing trigonometry. We'll be doing trigonometry. I hope you enjoyed, and yeah, thank you for attending and watching the video. Keep on watching. If you don't understand, watch the first video until this one. Watch them over and over again if you truly want to understand mathematics. And also study. Use Kevin Smith's study guide or any textbook that works for you. There is another one, Platinum. Use it to study and use the notes that I give you and the information. Practice more questions. You're gonna do well. Thank you.